All right, let's talk about a piece of technology you almost certainly use every single day, probably without even realizing it. It's more than just a protocol. It's kind of like the secret language that makes the entire modern cloud work. We are, of course, talking about Vxlan.
I mean, just stop and think about that for a second. It's kind of mind-boggling, right? Every time you use a cloud service, you're getting your own little secure bubble inside a gigantic data center. But how on earth does that data center keep your stuff separate from everyone else's? How does it create all these private virtual worlds on the exact same physical gear? Well, that is the giant puzzle we're going to solve today.
To really get why the solution is so brilliant, we first have to understand the problem. And to do that, we need to rewind the clock a bit, back to a time before Vxlan, when data centers were running smack into a hard, physical wall. It was a digital traffic jam of, well, epic proportions.
This right here, this was the number, the big limit. For a long time, the main tool for separating networks was something called a VLAN, and it could only create a maximum of 4,096 unique networks. Now, back in the day, that seemed like more than enough. But as you can probably guess, that number was about to become a massive bottleneck.
Because then, boom, the age of virtualization and cloud computing just exploded onto the scene. Suddenly, every single customer needed tons of isolated networks, dozens, sometimes hundreds of them. And that 4,096 limit, it wasn't a guideline, it was a brick wall. Progress was literally grinding to a halt, because the old way of doing things just could not keep up.
So the industry desperately needed a breakthrough, something that could just smash through that wall and give the cloud the kind of scale it was demanding. And that breakthrough had a name: Virtual Extensible Local Area Network, or, as we know it, Vxlan.
And what a breakthrough it was. Get this, Vxlan didn't just nudge the limit higher, it completely obliterated it. By using a 24-bit identifier, it took the number of possible networks from just over 4,000 to over 16 million. Yeah, the bottleneck wasn't just cleared, it was gone. Forever. Okay, so what is this magic? The official definition sounds a little dense. A Layer 2 overlay on a Layer 3 underlay. But don't worry, the idea behind it is actually pretty simple. Just imagine your physical network, the actual cables and routers, as all the local streets in a city. Vxlan basically builds a whole new system of virtual superhighways that runs right on top of those streets, totally independent and way bigger.
And to really wrap our heads around this, let's use an analogy. This is probably the easiest way to understand how Vxlan does its thing. So for a minute, let's forget all about computers and just think about something simple, like mailing a letter. So here's how it all breaks down. The underlay, that's our physical network. Think of it as all the real-world roads, the airports, the delivery trucks. It knows how to get a package from a physical address in one city to a physical address in another. Now, the overlay, that's our virtual Vxlan network. Think of this as the post office itself. The post office doesn't own the roads, right? It just uses them to deliver mail based on its own internal addresses, like from one person's desk to another's.
So, how does this virtual post office actually use the physical roads? Well, the secret sauce, the one key process that makes this whole thing possible, is something called encapsulation.
And honestly, that's all it is. This is the whole trick. You take your original piece of data, your letter, and you just seal it inside a brand new outer envelope. The physical network, the delivery truck, it only ever looks at the address on that outer envelope. It has absolutely no idea what's inside. And here's what that looks like in the tech world. That original inner Ethernet frame, that's our letter. Vxlan then wraps it up in all these new outer headers. That whole package is the new envelope. The physical network just reads those outer bits to make the delivery. The original packet tucked away inside, it's just cargo as far as the network is concerned.
So this whole thing boils down to a really simple three-step dance. First, the entry point to our virtual network. It's called a VTEP, which is basically our local post office. It maps the destination to figure out which remote post office to send it to. Second, it encapsulates the packet, puts our letter in that new envelope. And finally, it just forwards the package to the physical network, which delivers it, completely oblivious to the secret message inside.
Okay, so we know Vxlan can create millions of these virtual networks by basically putting packets inside other packets. Cool. But in the real world, this awesome tool is used in two main ways. We call them bridging and routing. And we can stick with our mail analogy here, because it works perfectly. Think of bridging as sending mail between two desks in the same office building. The computers are all on the same team, part of the same subnet.
Routing, on the other hand, is for connecting different networks entirely. This is like sending a package from your company to a different company across town. They're on completely separate teams or different subnets, and you need a way to link them up.
And you can see it pretty clearly here. On the left, you've got bridging. It's taking one network, Vxlan 10, and just stretching it across the physical gear. This makes host A and host B feel like they're sitting right next to each other, even if they're in different buildings. Then on the right, you've got routing. This is all about connecting two totally different worlds, host X's network and host Y's network, so they can talk to each other through that Vxlan tunnel.
So we've got the theory, we've got the analogy, but what does this all mean in practice? What are the really big benefits, and what are the things you have to kind of watch out for?
Okay, this is why it really matters. Because that virtual network is completely disconnected from the physical one, you can stretch a single, seamless network across entire continents. That server in the US and that server in Germany? Yeah, with Vxlan, they can be part of the exact same network, like they were plugged into the same box. This gives cloud providers an absolutely insane amount of flexibility. But it's not pure magic. There are a few things to keep in mind. Remember that new envelope we talked about? Well, it adds about 50 bytes to every packet. So you have to make sure your physical network can handle these slightly bigger jumbo frames. You also have to make sure all your post offices, your VTEPs, can actually see and talk to each other over the physical network. And finally, to make sure everything works smoothly, they should all be listening on the same channel, which by default is UDP port 4789.
So, the big takeaway here is this. Vxlan is a perfect example of a really powerful trend in technology. When you hit a physical limitation, you just build a smarter, more flexible virtual layer on top of it to solve the problem. It basically freed the network from the chains of physical hardware. And that leaves us with a really interesting question to think about. What physical limits are we hitting today, and what brilliant new virtual layer are we going to invent next to get past them?